Hi, I am Fadi, and in this recording I am presenting my 2026 Cvpr paper, the paper titled Idperturb, Enhancing Variation in Synthetic Phase Generation via Angular Perturbation. Our work targets enhancing variation in synthetic data used in face recognition training. Traditionally, real data has been used to develop face recognition. However, there is technical limitation in collecting large, diverse, and representative real data. There is also increasing privacy, legal, and ethical restriction in collecting, sharing, and redistributing real data. And therefore, many of the database that has been widely used in the literature has been retracted by their creator. Very recently, synthetic data has been emerged as alternative to authentic data to train face recognition. Most of the recent state-of-the-art approach utilize identity condition diffusion model to generate a synthetic data for face recognition training. The main challenge for the recent state-of-the-art approach is that the generated data by this approach often contain a few intra-class variation, and our goal here is to generate a diverse yet identity consistent data for robust face recognition training. Here we have an overview of our proposed approach. We start by the input identity embedding vector. We then normalize it on the unit hypersphere, and then we apply our geometric method Idperturb, where we perturb the embedding within cosine constraint cone around this input embedding vector. The cone boundary is defined by the lower bound hyperparameter LP, and this hyperparameter defines, as I said, the cone boundary. And when we have lower value of the lower boundary, it means we have strong perturbations and more diversity in the generated data. And when we have higher lower bound value, then that means we have strong identity preservation and less diversity. And then using each of the perturb embedding as identity condition for a diffusion model, we sample a set of images that belonging to the same identity with high intra-class variation. Visually, here we have some sample generated by the baseline without Idperturb, and with different samples that generated from our Idperturb approach with different lower bound, which, as I mentioned in the previous slide, is defines a cone boundary. So we can see here when the lower boundary is decreased, we have higher variation, for example, in head pose, expression, appearance, and age related. This visual result also supported by the evaluation of different attribute classifier, the intra-class diversity metric, intra-class consistency metric, and face recognition performance. We see here that when the lower boundary is decreases, we have higher variation, for example, in age, in head pose, in expression, as well as in general intra-class diversity metric. On the other hand, we can see also when the lower boundary is decreases, we have less intra-class consistency. However, the face recognition performance in general is enhanced when the intra-class diversity is increased. This plot here shows a trade-off between diversity and consistency of the data generated by different lower bound value with the face recognition performance, and we can see here that the point here in this plot that provides the best trade-off between intra-class consistency and diversity lead to best face recognition performance. To put that into perspective, with the state of the art, we compare our approach with all previous state of the art, and we can see here that our approach enhances the state of the art performance on the most of the considered benchmark, and as well as on the large challenging IGBC benchmark. Our take-home messages: in this paper, we presented Idperturb, a geometric-driven sampling method for identity conditioned diffusion model. Our method enhances the intra-class diversity in the generated data by diffusion model, and this is also reflected on the face recognition performance. Our method does not require any retraining or special architecture design, and it can be integrated with any identity condition diffusion model. With a comparison of the state of the art, our approach enhance state of the art result on most of the considered benchmark. Thank you for listening.